Hello everyone. In this lecture, I am going to discuss some problems on the continuity of functions. So first problem is fx equal to x sine 1 by x not equal to 0, and 0 if x equal to 0. So fx is defined like this, and we have to check the continuity of this function at x equal to 0. Now, to check this continuity, first we have to remember the squeezing theorem. That means your sandwich theorem, that if limit fx equal to L as x tends to a, then limit g of x as x tends to a is equal to L. So suppose limit of fx is equal to L, limit of gx is equal to L, then if there is a function h in between f and g, then the limit of h also will be L. Okay, so limit of f equal to L, limit of g equal to L, then limit of h as x tends to a will be equal to L. So this is the squeezing theorem or sandwich theorem. So we will apply this theorem in this problem. So now we know that the value of sin x is always value of sin x is always in between 1 and -1. The minimum value is -1, maximum value is +1. So we have to check your function is x into sine 1 by x when x not equal to 0. So to check the continuity, first what is the conditions we have? One is we have to check the limiting value will be equal to functional value. If your functional value exists, then we have to check whether it is equal to limiting value or not at that point, and point is x equal to 0. So limit of fx at x tends to 0 and must be equal to f0 for the continuity of this function. So first we have to find the limit of function. So to find the limit, we have to use your squeezing theorem. So to use the squeezing theorem or your sandwich theorem, we take what? Sin x. The value of sin x is in between 1 and -1. Okay, so now since we have sin 1 by x, so let it be sin 1 by x. So sin 1 by x is in between -1 to 1 always. So multiply x throughout the inequality. So it will be minus x less than equal to x into sin 1 by x. Sin 1 by x is equal to x. Is not it? So now take the limit as x tends to 0. Now take limit as x tends to 0. So x tends to 0 minus x, then it will be 0. Now if limit x tends to 0 x, it is also 0. And since x sine 1 by x is a function is in between minus x and x, so by and limit of minus x is 0, limit of x is 0, and that's why using squeezing theorem we can say that limit of this function is also 0 as x tends to 0. So that's why limit of x tends to 0, x sin 1 by x is equal to 0. So this is the limiting value. This is the limiting value. Then we have your functional value. What is the functional value? That is your f of 0. So when x equal to 0, your functional value is equal to 0. It is given. So f of 0 is equal to 0. So what we got? We got your limiting value is equal to 0. Its functional value is equal to 0. So limiting value is equal to functional value. So f is continuous. So f is continuous at x equal to 0. Clear? Now come to the next example. Next example is a function is given and it is given that function is continuous. What is the function? Function is given like fx is equal to this. This is your given function. Fx equal to ax square plus b when x less than 1, 1 when x equal to 1, 2ax minus b when x greater than 1. This is your given function. And another given is it is continuous. It is continuous. It is continuous. It is also given. It is continuous at x equal to 1. Okay. So if it is continuous, then find a and b. Find a and also we can check whether it is continuous or not. For continuity, we can check its limit, its functional value. If both are equal, then it will be continuous. Okay. So you can also check when limiting value, once your left hand limit x tends to 1 minus. So if it is 1 minus means less than 1 means function is defined by x square plus b. So you can put here ax square plus b. So if you put 1, then it will be in place of x we put 1, is not it? So it will be a plus b. This is your limiting value, left hand limit. Okay, then your right hand limit means limit x tends to 1 plus 2ax minus b, because 1 is plus means it is greater than 1 and it is defined by 2x minus b. So the value will be what? 1 plus in place of x. So 2a1 minus b. So it will be 2a minus b. So this is your right hand limit. And since your function is continuous, so your limit must exist, and for the existence of limit, your left hand limit and right hand limit must be equal. Is not it? Right hand limit and left hand limit must be equal, and both should be equal with your functional value. Both should be equal to with your functional value. And what is your functional value? X is equal to 1. At x equal to 1 means f of 1. So functional value is f of 1 when x equal to 1. Function is defined as what? Fx equal to 1. So f of 1 is 1. Now these three must be equal: a plus b, 2a minus b, and that must be equal to 1. Okay, so what you got? We got a plus b is equal to 1, because your left hand side must be equal to functional value. Then the right hand side must be equal to functional, means right hand limit 2a plus b or 2a minus b. 2a minus b, that must be 1. Okay, so now you can check the value of a and b. You can find value of a and b. So if you add it, b and minus b will be cancelled. So 3a is equal to 2. So a will be what? A will be 2 by 3. Okay, so how did we get it? Because function was continuous. And for the continuity, your limiting value must be equal to functional value. further limiting value, your left hand limit must be equal to right hand limit. So your left hand limit, this is your right hand limit, and left hand limit is equal to functional value. Right hand limit is also functional value. So that's why we have got two equations, and we have to solve this two equation to find the value of a and b. So a equal to 2 by 3, then put it in the equation a plus b is equal to 1. So if a equal to 2 by 3, so b will be 1 minus 2 by 3. That is your 1 by 3. Right? So the final answer is a equal to 2 by 3, b equal to 1 by 3. Clear? Next to come. Next example is discontinuity. We have to check the continuity of your the function fx is also it is called Dirichlet function. fx equal to this, fx equal to 1 if x is rational, and 0 x is irrational. X is 1 fx equal to 1, x is rational, 0 x is irrational. That is why, means that is how function is defined, and we have to check whether it is continuous or discontinuous. So what is your claim? It is discontinuous. It will be discontinuous. How? So to check it, just check some reasoning. What are the reasons? In every neighborhood, for any x0, there are both rational and irrational numbers, because in any neighborhood means if we take some interval, x0 is a point, then in between, if I take an interval around the point x0, then there are so many rational and irrational numbers are there, isn't it? There are so many rational and irrational because these are the real numbers. So it contains all rationals and irrational numbers. So there are infinite number of rational and irrational numbers around a point x0. Okay. Now the function takes both 1 and 0 infinitely. That's why the function takes the values both 1 and 0, because when it will be rational it will be 1, when it is irrational it will be 0. And if it takes both the values, then your limit does not exist, because when it will be rational it will be 1, when it will be irrational then it will be 0. So their limiting value will not exist. If limit does not exist, then it will be discontinuous. Understood? Or otherwise you can also write like this: your left hand limit LHL will be equal to limit, because you have to check at 0 or in any point, suppose any real number, suppose it is 0, x tends to 0. So left hand limit means x tends to 0 minus fx. Now x tends to 0 minus means in our working formula we can write it as limit h tends to 0 f of 0 minus h, or limit h tends to 0 f of minus h. 0 minus h means minus h, so f of minus means this value. So here h may be rational, may be irrational. Here h is rational or irrational, may be rational, may be irrational, because it tends to 0. It is not 0, it tends to 0. So if it is rational, this value will be 1. If it is rational, this value will be 1. If it is irrational, then value will be 0. So this takes both the values 1 and 0. It may be 1, it may be 0. So it will not give a particular finite value. Okay, so that's why it has both, since it has two values, so that's why limit does not exist. Limit not exist. Limit does not exist. Okay, and since limit does not exist, function will be discontinuous. So you can take any real number. At any real number, function will be, so that's why for any real number, function will be discontinuous. Function will be discontinuous. Okay, this is not the problem. Problem is this: function is discontinuous at every point on the real line. F is discontinuous. That's why f is discontinuous at every point on the real line. You can take 0, you can take 1, you can take 1.2, any point, any real number, this function will be discontinuous. Same problem, means this type of problem is there in the next slide, but function is just different. What is the function? If x is rational, then it will be x, and if x is irrational, then it is minus x. How it is defined? X and minus x. Okay, so if you check again the continuity of this function at x equal to 0, at 0 it will be continuous. How? Limit x tends to 0 minus for your left hand limit. So if it is 0 minus fx, so if x equal to rational or irrational, the value will be x or minus x. And since x tends to 0, the value will be x or minus x according to rational or irrational. So if it is x and minus x and x tends to 0, so for both the cases, the value will be 0. For both the cases, the value will be 0. Okay. Similarly, the right hand limit also 0. Similarly, the right hand limit x tends to 0 plus your fx is x or minus x according to your rational or irrational, because 0 plus may be rational, may be irrational. So in both the cases, it may be x, it may be minus x. So if it is x, as x tends to 0, it will be 0. If it is minus x, it will be 0. So in both the cases, rational, whether it is irrational, both will be 0. So your limiting value, both are 0. And what is your functional value? F of 0. F of 0, and if it is 0, x 0 is rational, so it will be x, and at the time 0, so it will be 0. In place of, if we put 0 in place of x, then it will be 0. So functional value is also 0. So limiting value is equal to functional value, so the function is continuous. So the function is continuous. So the function is continuous at x equal to 0. Now, if it is not equal to 0, for any x0 not equal to 0, when x not equal to 0, and this function will be discontinuous, because the suppose point is x0 or x0. When approaching x0 through rational, then the value will be x0. And if we approach x0 through irrational, when we approach, the value will be minus x0, because x and minus x is there. For x it will be x0, for minus x it will be minus x0. So there are two values, two limits, is not it? Two limits are there, and since two limits are there, so limiting does not exist. Limit value does not exist when x0 not equal to 0. Okay, so what is our result? F is discontinuous at x not equal to 0, and f is continuous at x equal to 0. Okay, now come to next example. So next example is the existence of the solution e to the power x minus 2. Okay, and we have to check there is a solution in between 0 and 1. There is a solution e to the power x minus 2 in between 0 and 1. So to check it, first we have to explain, or we have to know the intermediate value theorem. Intermediate value theorem. So what is this theorem? What is this theorem says that your if your function is there, f is a function, and suppose there are 2 points a and v, such that f a into f of v less than 0. Okay, f is a function and there are 2 points a and v, such that f of a into f of b less than 0. That means what? F of a and f of v have opposite signs. If f of a less than 0 and f of v greater than 0, then their product will be of negative sign, less than 0, or f of a greater than 0, f of b less than 0. So they must be opposite signs. If they have opposite signs, then their product must be less than 0. Okay, so if this product will be less than 0, then there is a root, there is a solution of this function, there is a root. Root means your, if fx equal to 0, then there is a solution, x is called the root. Okay, so then there is a root in between a and b. Suppose c, the root is c, so there is a root in between a and b. There is a root c in between a and b. Okay, so this is your intermediate value theorem. Now, by applying this theorem, we can find the solution. So first we have to check it is continuous function. If it is continuous, then this intermediate value theorem holds. Okay, so for the intermediate value theorem, function must be first continuous. First function must be continuous. Now function is what? E to the power x minus 2. So now we know that e to the power x is always continuous. Exponential function is always continuous. E to the power x, and minus 2 is a constant. So we know that f minus g, if f is constant means continuous, g is continuous, then f minus g is also continuous. So that's why exponential is continuous, this is a continuous function. So their subtract means your difference is also continuous. So the given function e to the power x minus 2, e to the power x minus 2 is continuous. And since it is continuous, then we have to check the what the given interval is 0 1. Given interval is 0 1. So put f of 0, find f of 0. So f of 0 means e to the power 0 minus 2. So e to the power 0 minus 2 means 1 minus 2, that is minus 1. Then find f of 1, because the endpoints of this interval is 0 1. So let it be a, then v. Then find f0, f1. So what will be f1? E to the power 1 minus 2. So e to the power 1 minus 2 means, e to the power means what is the value of e? This is your 2.718. This is your 2.718 minus 2. So the value will be 0.718, which is greater than 0. Which is greater than 0. So it is positive. Then f of 0 is negative. So they have opposite signs. They have opposite sign. Therefore we can write f of 0 into f of 1 less than 0, and f is also continuous. Therefore f is continuous, f0 f1 less than 0. So by intermediate value theorem, by this theorem, we can say there is a root in between 0 and 1. So we can say, since exists c such that fc equal to 0. Fc equal to 0 means there is a solution of fx equal to 0. There is a root of the function. So f of c equal to 0. So what is c? C is in between 0 and 1. Okay. So we can say there is a root in between, and there is a root exists in between 0 and Clear? Now come to another example. This is the final example for this lecture. That uh, so that, what is your question? Question, this is also question of your book. So that x is equal to cos x. So that x equal to cos x for some x, for some x in 0 to pi by 2, in 0 to pi by 2. So this is what we have to prove. So x equal to cos x, we have to show that. So we have to assume some function is equal to x minus cos x. Just assume gx is equal to x minus cos x. Now see here, x is a continuous function, this is a polynomial function, this is a trigonometric function cos x. We know that x is continuous, cos x is continuous, because we, in the previous lecture I have already told that polynomial function is always continuous, trigonometric function is also continuous, so their difference is also continuous. So your gx is continuous. So your gx is continuous function. Now you can check the interval is what? 0 to pi by 2. On this interval we have to check x equal to cos x. So that's why we take the value g of 0. Since we take g equal to x minus cos x, so g of 0 will be 0 minus cos 0. Put in place of 0, 0. Just put 0 in place of x. So 0 minus cos 0. So that is your minus cos 0 money 1. So this is minus 1. And what is g of 1? G of 1 means put 1 in place of x. So it is pi by 2 minus cos pi by 2. So that is your pi by 2, and cos pi by 2 is 0. So it is only pi by 2. Now see here, g of 0 is negative and g of 1 is positive. G of 0 is negative and g of 1 is positive. So g of 0, now we can write g of 0 into g of 1 is less than 0, and already we have checked that g is continuous. So we can apply intermediate value theorem. So according to intermediate value theorem, there exists some x belongs to 0 to pi by 2. There is a root in between 0 to pi by 2. There is a root in between 0 to pi by 2, such that your g of x is equal to 0. G of x equal to 0. So therefore, g of x is what? X minus cos x equal to 0, and therefore x equal to cos x. Okay, so this x is equal to cos x, and what is x? X is any value in between 0 to pi by 2. So there exists some value that suppose it is c. That's why here we have written that some c exists 0 to pi by 2, so that g of c equal to 0. So c equal to cos c. So for any x is equal to c. Okay, and for the uniqueness we can check its derivative, and since we not yet discussed your derivative, so just you can check your uniqueness, take its derivative, it will be 1 plus sin x, and which is greater than 0 and is strictly increasing, and thus the root is unique. Okay, so to check this x equal to cos x, you can take the function as x minus cos x and check it first whether it is continuous or not, and whether at the end of the endpoints of the interval take it the value have your opposite signs or not. If they have opposite signs, then their product will be less than 0. Okay, the product will be less than 0, and we can apply the intermediate value theorem. And what the intermediate value theorem says, there will be a root in between these two endpoints. Okay, there is a root of the function in between the endpoints of the interval. Understood? Okay, so thank you everyone. So subscribe this channel and to get this type of problems and with the solution. And if you have some doubt, then you can also ask me, and I will try to clear the doubts with the other problems, using the other problems. And in the next lecture again we will meet and to discuss the next part of the, means suppose we will come to the differentiability of the function, we will come to the integrability, integration of the functions. Okay, so just subscribe the videos to get more and more videos. Thank you.